I've been working in IT now for over 30 years, and I've been at the Very Group for 27 of those years, so quite a long time. During that time, I've worked in a number of roles, starting out many years ago as a PL SQL developer before moving on to be an Oracle database administrator, a middleware consultant, and then ultimately back into Java development back in 2007. I was heavily involved in setting up the embryonic cloud engineering team at that point, and I've been managing teams in what is now the platform engineering team ever since. So I'm really passionate about platform engineering and building the right products for our customers to consume, and I spend a great deal of time ensuring that we're doing just that and collaborating with engineers across the development community at the Very Group. So why am I here today? Well, I'm here to talk about how platform engineering has evolved at the Very Group over the years and the challenges that we've faced during that time, and how we've built a successful platform for our engineers to deliver great products on top of. The ability to constantly evolve our platform is a massive part of ensuring the success of platform engineering at the Very Group, and I hope that you enjoy our story today. So let me tell you a little bit about the Very Group. So we are the UK and Ireland's largest integrated digital retailer and financial services provider, and we're really attractive to our millions of customers because we offer a massive variety of brands with many options to spread the cost of purchases as well, which is obviously really important at the moment. This is our headquarters in Speke in South Liverpool. We're based. Our head office, Skyways House, is one of the former aircraft hangars of the original Liverpool airport. We moved here in 2006, and the picture on the right is in 1964 when it was still an operational hangar, and it's been slightly obscured by a local pop group who went on to sell quite a few records. So what is platform engineering? Well, platform engineering is a fairly new discipline, but one that's taken off globally over the last few years, really. It emerged as a direct response to the growing complexity of modern software architectures, and simply put, platform engineering focuses on building and maintaining infrastructure and platforms that support the software development process. This includes tools and capabilities such as continuous integration, continuous deployment pipelines, containerization, monitoring, and orchestration. And if it's done to a high standard, it should enable self-service capabilities for software engineering teams working in the cloud. So this is our mission statement, and it's quite wordy, but we exist to help our developers succeed by creating a path of least resistance for developing software, and by making the right thing to do the easiest thing to do. So what does all that mean? Well, it means that we're here to remove as much of the treacle as possible for our developers. We want to let our developers focus on functional delivery and not have to worry too much about the underlying platform technology. It also means that we will build our products with built-in guardrails, standards, and documentation, and to make them easy to consume and use. We want to create a platform that is the default choice for all of our developers, and we do that by ensuring that we only build what our developers actually need, and we achieve this by only building things in collaboration with our development community at the Very Group. So what does the team look like? So I have a team of 10 platform engineers working on things like the CI/CD capability, AWS infrastructure development using Terraform, account design, disaster recovery, and we've recently started looking at internal developer platforms as well, and I'll talk a little bit about that later on. And what about the development community at the Very Group? Well, our company is organised into tribes which are aligned to business domains, each of which has an IT capability, and the tribes are split into a number of squads. And platform engineering underpins those tribes by providing them with platforms, products, and services. Pardon me. So at the Very Group, platform engineering has become the enabler for software delivery. And here's a quote from Kyle, who's one of my principal platform engineers, and I think it captures what we're here for really well. I won't read it out, but you can see the things that have been highlighted of importance. When we're not perfect. We've made mistakes along the way, and we're working every day to ensure that we're doing the right things for our internal customers. And we do this by working closely with our developers and by constantly reevaluating our platform products to ensure that they're always fit for purpose. My job is to ensure that we only build products that are going to be of value to the tribes, and this is where the evolution of the platform is so important. So for this presentation, I asked my team to provide some quotes to describe the value that they see platform engineering adding to the very group. And these were things that stood out. So we provide best practice as standard, and everything that we do is to match the standards and the best practices that we've defined as a company. We provide consistency, and we promote that as well. So we're trying to put a platform in place that is consistent across the board. We allow for innovation. So we want our developers to be able to express themselves as well as deliver value for our customers. The developer experience is really important. We want using our platform to be a great experience for everyone who uses it effectively. And we bake in guardrails. Security comes as standard with everything that we do. And we have standardized and reusable components. So again, the standards that we define are built in, so developers don't have to worry about creating those things themselves, worrying about making sure that they're standardized. So yeah, driving business success. This effectively is our ultimate aim, and this can only be achieved if we get the platform right. We want to empower developers. We want our tribes to be autonomous, and we want them to be able to, we want to be able to empower our developers to build solutions that they need to deliver. We also want to speed up development and deployment cycles. Obviously, the platform should absolutely smooth the path for quicker development and deployment. We failed if we're not providing products that do this effectively. And and then we come to cognitive load. So, what is cognitive load? Well, this is the total amount of mental effort being used in the working memory. And the theory around cognitive load asserts that learning is hampered when working memory capacity is exceeded by a learning task. So why is that so important to us? Well, if the platform products that we develop need the developer to spend hours, days, weeks, etc., learning a new piece of tech, and this is going to have a massive knock-on effect on their ability to deliver functionality for our customers. So the idea is that the platform engineering team builds abstraction layers and platforms to shield developers from the complexity of underlying technologies and to therefore reduce cognitive load. And this is what we've hopefully done and continue to do at the Berry Group. But how do we ensure that we're not increasing cognitive load and that we are providing all of the things that my team say that we're here to do? Well, we do this by constantly evolving our platform and products and by collaborating with our customers to ensure the evolutionary steps that we take are driven by the correct factors. So, what forces the evolution? Well, just like in the natural world, these things, environmental pressures, constraints, natural selection, survival of the fittest. So from a tech point of view, environmental pressures can be things like organizational structure, project deadlines, technological advancements, security and compliance requirements, user experience and considerations, and things like cost as well, and also being in a position to take competitive advantage. Constraints, what are the constraints that we have at the Berry Group? Well, we're a FCA regulated multi-billion-pound retailer, so we're not a startup, so we don't have the option to sort of introduce tech without quite a lot of a considered approach. And the team size as well is a constraint. We are a finite team, and like I mentioned before, so we must choose our battles wisely. Natural selection and survival of the fittest. Well, once a tech choice has been made, user interaction and constant evaluation ensures that this tech is still fit for purpose, and that's an ongoing evaluation piece, really. So overall, the constant evolution of IT platforms is essential for organizations to remain competitive, secure, and adaptable to changing requirements. So how did platform engineering come about at the Very Group? Well, if we go back in time, 6 years or so, back in 2017, we had a problem in the e-commerce team with the monolithic website application. We were only deploying code to production every 2 weeks or so. And this took overnight releases with huge amounts of manual testing and release management activities. Pardon me. We had a dedicated release manager for this, and he had to put together complicated schedules of events for each release. So it was obviously very time consuming. And as a result, we started to look at breaking up the website application. So we put together a small team of developers to look at doing this. And this was effectively the embryonic cloud engineering team that would become the platform engineering team 2 or 3 years later. So what was the problem that we were trying to solve? Well, how do we deploy changes to our website application more frequently? And how do we do it with less disruption? And the factors that were forcing the change, well, simple really, as a major online retailer, we needed to be in a position where we could respond to the changing needs of our customers very quickly, and to be in a position where we could keep up with and overtake our competitors. So the approach that we chose, well, we decided to go with the microservice approach, breaking up the monolithic application and introducing a culture of CI/CD. So we made some tech choices based on the following constraints, things like the existing knowledge and skills within the team. So the team at the time was made up of 1 lead developer and 6 apprentice developers. The ease of use of the technology and the cost of the technology as well. So they were the things that constrained us at that point. And what you can see here was our first sort of step on the evolutionary ladder. And we went with AWS Cloud, with using CloudFormation as the infrastructure as code language, Jenkins for CI/CD, Docker for containerization, and using the AWS services, ECS and EC2 for hosting the applications. We use Bitbucket as a source code management system, and we use Java Spring Boot as our development platform. We felt that breaking up the single monolithic application into smaller, self-contained, decoupled units of functionality would give us the ability to deploy changes more frequently. So we did this. We did that, and then what did we actually achieve? What did this first platform actually enable? Well, we didn't quite achieve exactly what we were hoping for. And evolution, as we found out, quite often leads to unexpected results. For example, who'd have thought that 100,000 years of human evolution would have led us to this? And I can't see if people are laughing at this point at all, so we'll quickly move on. So breaking up the monolithic website application that had taken 70-odd developers 3 years to produce actually turned out to be a much bigger task than a team of apprentices and 1 overworked contractor could deliver. But we had proved the concept of microservices, containerization, and CI/CD. So we went on a slightly different journey instead at that point. So this first platform enabled the creation of a microservice-based CI/CD culture at the Very Group. And this actually led to the creation of the business domain-focused tribes that we have in place today. So we had our initial platform, but this was obviously just a start. We wanted to show that this to our development community, and more people started to adopt it and learn about the technology involved. At this point, we started to get a lot of feedback and requests for enhancements. So we adopted this way of working that we have in place today. So we work with the tribes to understand the problem. We then work together to ensure all interested parties are included in designing a solution. We as the platform team then go away and develop the solution, and then we collaboratively review the finished product. So we now had a lot of interest in the platform, and we developed a Java Spring Boot microservice template for EC2 on ECS in AWS, and this became the default platform for microservice development at the Very Group. So we were really starting to show our value as a team at this point. We did develop Jenkins pipelines and CloudFormation, and developers out in the tribes were now starting to skill up in these areas. So it was really, exciting time. So as adoption of the platform accelerated, we started to look for areas of improvement, and one of the areas of improvement that we identified was in the infrastructure as code space. So what was the problem? Well, CloudFormation that we were using was not flexible enough for our multi-account use case. For example, we couldn't deploy cross-account easily, and we couldn't modularize standard components. It was too verbose, and we needed something more programmatical and a more standard way of defining infrastructure. Why did we need to do it at that point? Well, a multi-account, multi-tribe environment was being introduced, which made cross-departmental standardization difficult with the CloudFormation models. That was the main reason, really. So this led to our first evolution. And what you can see there is we moved from CloudFormation to Terraform and Atlantis. So the move to Terraform allowed us to create standardized Terraform modules for different AWS services. It gave us the ability to create separate repos for each environment, thereby making it easier to version and test infrastructure in different environments. We reduced the feedback loop between infrastructure code development and deployment using Atlantis, and the standardized approach made infrastructure more secure and consistent, and therefore significantly reduced the amount of support that my team were having to provide to the tribes. Other things that we introduced at this point included a centralized login solution, monitoring and alerting capability, AWS service control policies to ensure developers were not spinning up non-standard infrastructure and services. And we introduced the serverless capability at this point as well, using Fargate and Lambda. So at this point, we've moved to Terraform, but that wasn't the end. We carried on reviewing our platform and working with our customers to ensure that we were using the best products. And this led us to our next pain point. And this was source code management. So at the start, we had decided to go with Bitbucket in the cloud as our source code management solution. This was our first Git-based platform and was fine initially. However, we had little budget for this, as most of the company was still on legacy source code management systems such as Subversion. And as we ramped up usage on Bitbucket, we started to see issues with performance and stability. We'd quite often get outages and couldn't get the support that we needed on the version of Bitbucket that we were using. And we also had very little control over backups. So we decided as a company to review our options and collaboratively made a choice to migrate to a self-hosted version of GitLab. So as you can see there, go on to the next slide, please. Thank you. This was our second evolution. So we also introduced AWS Single Signon at this point. This allowed us to take advantage of the Azure Active Directory-based Single Sign-On capability that we already had in place at the very group, and to greatly improve our security around AWS identity and access management. So that was a big win, really. So as the platform was now widely adopted, we had to ensure we were also refining the non-technical side of the platform. So things like the introduction of FinOps. So AWS was now widely used across the team. So we had to get and keep control of costs and to educate all AWS users on implications from the financial point of view that using services in the cloud introduced. Obviously, we were suddenly in a place where it was very easy to provision things quickly, and as a result, costs can spin out of control. So to get a bit of control over it, we hired a dedicated FinOps expert and embedded him in the team. It was his responsibility to build relationships with each tribe and to work with them on areas such as cost optimization, and working with them also to ensure that the best option was always chosen for each type of resource that they were using. He also worked closely with AWS on things like savings plans and the usage of reserved instances to maximize our savings effectively. And this ended up saving the company round about $1 million in the first 2 years, so it was really worthwhile. And then from a DevSecOps point of view, we actually embedded 4 security consultants in my team as we defined the security guardrails for working in the AWS cloud. Pardon me. These guys also work with the team to define the security elements that should be baked into the software development lifecycle. And this led to things like the introduction of threat modeling as a step in the SDLC that we still use today. And then we looked at shared responsibility models. So as we now had a platform engineering team and a number of tribes using our platform, it became clear that we had to produce shared responsibility models to make it clear to everyone who was responsible for what effectively. We documented this for each area of the platform, and this made it clear to the development community the things that they would be expected to build and maintain, and probably just as importantly, when to actually engage platform engineering. So as the platform was now widely adopted, we had to ensure that we had very clear lines of communication in place between us and the tribes to ensure that we continue to succeed, because communication is key to success. We found communication to be the biggest problem that we've had to solve. Tribes are separate, autonomous units by definition, all focusing on their deliverables and inward facing. So getting requirements in from your customers is the single most important factor that decides the success or failure of a platform engineering team. So how we approach this? Well, a number of ways really. Communicating with colleagues was easy before March 2020. And then obviously, as we all know, the world changed forever at that point. Gone were the days of face-to-face meetings and coffee queue conversations and just being able to go and nab people at the desks, and no more ad hoc whiteboard discussions after bumping into someone in the corridor. So all of these things had to be sort of replaced. And I know everyone had the same problems at exactly the same time. We had to work really hard to ensure we could still communicate in the now 100% working from home world. So how did we do it? Well, we introduced a weekly all tribes meeting to get everyone together on a Teams call, where we would talk in detail about the work going on in platform engineering, the work going on in the tribes. We'd demonstrate the products that we were building, and we'd get updates from all the tribes in terms of what they were working on. So holistically, the visibility of what was going on was good. And we get requirements in from across the board for products that we should be building or amending. So this meeting, as I say, enabled holistic communication across all tribes and helped increase visibility of the platform products. It also led to more collaboration on the platform and allowed new starters to build relationships with other developers and platform engineers and platform engineering as well. And this led to more buy-in in terms of the platform, which was really important, and meant that we had a decent forum for requirements discussion. We then put other meetings in place, such as a monthly platform engineering community of practice and a monthly tribe alignment session. We also had fortnightly sessions with each of the tribes, so we could deep dive on things affecting that particular team. So engagement in these sessions is always a challenge, as developers at the very group, just like everywhere else in the world, are always busy, always working to tight deadlines. So trying to find time is a problem for everyone, really. However, bringing people into the conversation and showing them that we're here to deliver products to help them do their jobs meant that we actually succeeded in building the right products for our customers. So in terms of engagement, and engagement means if we get that engagement right, we build the right product. And if we build the right product, then people will automatically use the platform. And if they're using the platform, they'll come to us with product enhancements. And if they do that, we get the automatic engagements, and so on and so forth. So getting that right is absolutely key. Can't stress that enough, really. Success is based on two-way communications. So speak to your platform team. We don't bite, except on Mondays occasionally. So by this point, we were fairly mature, and we had all of the tribes using our platform, which was great. We had processes for gathering requirements in place, and we had all the lines of communication set up and in use. So what came next? Well, standardization and technical standards. So at this point, we produced a load of technical standards. We actually went on site for a couple of days, I think, as a team, and locked ourselves away and tried to formalize everything that we've done and get it down on paper and turn it into standards that we could then sort of agree upon as a organization. These included standards on cloud computing, CI/CD, source code management, infrastructure as code, and so on. So why are standards so important? Well, the widespread adoption of the platform meant that standards were required to make it explicitly clear how the products should be used. We had a lot of new developers joining the company with different skill sets and backgrounds, and the standards helped with onboarding these people. And overall, when defined and applied properly, the standards provide a governance-based approach to software development and platform adoption, and also, most importantly, really reduced risks around security and compliance. So the standards evolve. Well, yeah, we review our standards every quarter and make sure they're amended in line with any technological evolutions that we put in place. So we seem to be in a good place now. What do? Do we take our foot off the pedal? Well, no, there are two options really at this point, and it seems a bit dramatic, but going back to evolutionary terms, there are really only two options on the table. At this point, we adapt or we die. If we stand still in IT, as I'm sure you all know, we lose competitive edge, we stagnate, and we end up with a lot of legacy technology that no one knows anything about and no one knows how to maintain, no one wants to maintain either. So we must avoid that. This is why we must constantly adapt and keep evolving the platform to ensure our developers are in the best position to deliver functionality for our internal and our external customers, I should say. Excuse me. So what problems are we facing today, and what things should we be looking at in the immediate term? Well, even though our platform products and processes are now mature, our product is still fairly disparate. Our product set is still fairly disparate, and there is no single place for our developers to go to consume the platform currently. So we're missing an internal developer platform and a portal as well. And this is what we're now in the process of designing. We're hoping to get the first phase of this out by the end of the year. An internal developer platform will provide a single place from which all of our products can be consumed. It will be the self-service application containing all of the knowledge about our products, resources, and environments, and it will be in one discoverable place, as I say. The aim will be to improve transparency of what platform engineering provides to the entire organization, and the IDP will reduce the probability of developers hopefully doing their own thing, as this will, again, hopefully contain all of the products the developer needs to solve their problems. We're designing our AWS account, redesigning our AWS account architecture at the moment to make it much easier for accounts to be spun up automatically and decommissioned when they're no longer needed. Our account structure currently matches the organization structure. We're trying to break away from that because obviously it's too rigid, and the organization structure changes over time. So we're breaking away from that as we speak. We're also looking at moving to GitLab software as a service. We've started conversations about that in the last few weeks, and if this does happen, it will free up my team to focus a lot more on the things that we've got on the books, like the internal development platform. So what does the next evolution look like? So we're going to go multi-cloud. We go on to the next slide, please. Thank you. We're going to be looking at Azure. We're going to be looking at Google Cloud Platform and Oracle. AWS will still be our default platform for most developments at the very group, but the other clouds are going to be used for things like Active Directory, data manipulation, quick lift and shift migrations from on-prem legacy applications. There's a bit of that work going on at the moment. The migration from Jenkins to GitLab CI is underway as we speak, so that's a big thing that my team are working on at the moment, and that's going to give us greater capability in the CI space. as well as meaning a lot less time spent on maintenance of Jenkins plugins as well, which has taken up a lot of time over the last couple of years or so. There's a question mark on there, and that's around AI. So what does this mean for us? Absolutely no idea at the moment, but it's obviously something that we're going to be looking at in detail over the next 6 months or so. It'll be interesting to see what comes out of that. So what does the future look like? So after this next evolution, who knows? But one thing is certain: what we look like in 2 years' time will probably be very different to what we look like now, by the nature of IT and the speed at which platforms are evolving in general. So in the meantime, we will grow our internal development platform. We'll constantly evaluate the products that we have in place, and we'll keep ahead of the curve by reviewing all new features coming out on the tech platforms that we have in place, as well as reviewing all new relevant tech. And that's a big thing that my team do as well. We'll be looking closely at AI, like I've just said, to see what competitive advantage we could possibly gain in that area. So that's going to be, like I said on the last slide, it's going to be really interesting. It's going to be interesting to see how that pans out and what that leads to over the next year or so. And we'll be keeping on talking to our developers. As we've seen, this will be the key to our success ultimately. And we'll definitely encourage our developers to keep coming to us with requirements for their platform. And we will keep on evolving. And that's it, really. That's the end of the story. So thanks very much for taking the time to listen to our platform engineering journey today. I hope you found it interesting and useful. And I'm happy to take any questions.
Thank you very much, Matt. Thank you. Big round of applause, please, for Matt. Excellent. Just like we did before, Q&A using the QR code there. Please do send the questions in. And I'll kick us off with, this feels odd talking to you on a screen. I don't know whether you can see me or not.
I can see you from, I'm looking at you from the back of the...
Perfect. Okay, cool. So I'll kick us off with a question. There might be people in the room here that are just starting or hoping to start their career in platform engineering. If you could give them one piece of advice, what would that be?
Well, that's a good question, I suppose. Platform engineering, traditionally over the last few years, if you can use the word traditionally for such a new thing, has attracted people from all different sorts of areas of IT. So we have people from operations, from software development, etc., and other places. So we get people coming in from all over. What we've started doing at the Berry Group is to bring people in directly now from university and train them up into platform engineering. Now, in doing that, what we've realised is that there's a really broad subject matter that needs to be covered to get people skilled up. Things like, obviously we use AWS, so going all the way through the AWS certification, the training around that is important. Getting across Terraform, things like Docker, we mentioned Jenkins and GitLab CI. All of these things are part of the skill set of a platform engineer. So my advice would be to anyone thinking of going into it, go into it with your eyes open, and realise that there would be quite a steep learning curve at the start of the career. But we've designed a boot camp internally at the Berry Group where we bring people into my team now and effectively put them on an internal training course that we've designed that covers all of those things for the first 2 months. And we've seen that within 6 to 9 months, 9 to 12 months, something around about that time, people are starting to become independent and are able to pick up pieces of work. So yeah, I would say go into it with your eyes open, realise that there's quite a lot of a wide range of skills that need to be picked up. But go for it. It's a really, really rewarding area to work in.
Fantastic. Thank you so much. You can also ask questions in real life if anybody wants to feel brave as well. Yes, down here. There, Mike is coming towards you. Don't worry. Well, a mic, not Mike.
Hello. Thanks, Matt. That was really, really good presentation. I did have a question about the second evolution you were talking about, because I was interested in the kind of iterative approach you've taken to upgrading your stack, specifically moving. Yeah. I don't think I saw that you moved away from using EC2 towards just serverless compute capacity, but what was that conversation like internally? Was there like dissent from that? I know because some people want to maintain control of the servers. What did that process look like for you?
Yeah, so we still have EC2 across the estate, so just to make that clear. So at that point when we started evolving, we started looking at Fargate and serverless development in general. In terms of people out in the tribes, it actually generally came from those people, because they realised early on that using EC2 implied maintenance effort. In terms of having to patch and keep things updated and so on. And obviously, developers like to focus on development. So AWS realized that quite early on and gave people the ability to focus on serverless development. So like I say, it came that way, really, rather than us going out to the tribe saying, this is something that you really should try. Well, we were doing that as well, but we were being met halfway by people saying we want to do this and we want to get stop using EC2, apart from those situations where we really need to.
Satisfied? Perfect. Okay. Any other questions from anybody live? Yes, perfect. Right, just behind you.
Hi. So I want to ask your opinion about this question. Which jobs do you think are in most danger because of the coming AI? Like, which jobs will be overtaken?
Probably mine, I would say, quite quickly. Which jobs? That's a really good question. What I touched on in the presentation towards the end was that we're going to be looking at AI in detail over the next 6 months or so. I'll be quite honest with you and say that we haven't really done an awful lot with it so far, so it'd be quite difficult to answer that. I would guess, having seen the ease at which we can go to ChatGPT and pull, ask it to write complex bits of functionality that software developers might be most at danger. But then, that's sort of flippant response, because ultimately, we're still going to need people to define the thing, that they want doing. And we're still going to need people to take anything that's created from an AI machine and do something with it. Certainly in the short term, package the thing up and deploy it, for example, and support, etc. So I think we're all safe for the time being, but maybe if we come back in a year's time and answer that question, it might be quite different.
Adapt or die, right?
Yeah.
Anybody else? Yeah. Anybody else in person with the question? No. Okay, we'll do one last one then, because we are running out of time. So thank you to whoever sent this question in. With your plan of multi-cloud providers, how do you rate them from heavily used to lightly used?
In terms of the most popular cloud user, cloud platform?
I imagine how you will use them.
Oh, we will use them, right? Sorry, yeah. So AWS will remain as our default cloud platform. So the way that we're set up at the moment, we have 6 tribes, effectively, all populated by teams of software developers. And I would say that currently 80 to 90% of the applications developed are deployed on AWS. We're starting to see an uptake a little bit in terms of Oracle and Azure. We are migrating legacy applications from our on-premise data centers into Azure at the moment via lift and shift. And there's one of the tribes as well, I think, that's looking at Google. But I think the split, certainly at the moment, is probably 80–90% AWS, and then the rest of it is probably split equally between the other 3 platforms. But certainly over the next year, I would expect the other platforms to start taking a little bit more market share, if you like, within the very group. But that's, again, to be defined.
Fantastic.